issues. So this is the 21st such session that we are conducting, and let us begin by taking up your queries. So first, I'll just take queries that have been asked on the Google form, and then we will take queries from the live comments or email. So first query has been asked by, I'll just put it over here. First query has been asked by engineer uh, Devlin. He's joining us from Oman, and he's a working professional. So he's saying for PB, let me just copy it. So for PEB structures, we are applying wind load on rafters down to up. But for truss, I am seeing people are applying wind loads downwards like gravity direction. What is the reason for that? So I think what he is trying to say is that, and I would just correct him that this is not valid only for truss or PEB. What you might have seen in some models is that suppose there are two pressure coefficients CPE and CPI. Okay, all of you are aware of CPE, external wind pressure coefficient, and internal wind pressure coefficient. So CPE, generally the directions of CPE are like this. I hope the screen is visible. So for general slopes of your pitched roofs, CP and CPE directions are like this, external pressure coefficient. Yes or no? So these are your external pressures on the roof, sorry, on the wall, away from the roof, away from the roof, away from the wall on the leeward side. So this is how you get CPE usually. And about CPI, what are we told for CPI? So for CPI, we are told that there are two possible directions. You have to consider both possibilities, and that is, once you should consider all the internal pressure coefficients acting towards the wall or roof. So you up. I hope the screen is visible like this. So you apply it towards. No, wait a minute. Let me just put it this way. Yeah, everything towards. So one direction will be like this for CPI. Okay, and other possibility of CPI will be everything away. So away from the wall also, away from the roof also. So now what is happening that you may see that in some, for some coefficients, the wind load might seem to be in the gravity direction like this. I think that was what your question was, that you have seen some models where you have where you have seen people applying wind load downwards to the top chord. So I think what you have been seeing is that many engineers, what they do is that they make two sorts of load combinations, or two load cases rather. One will be for external wind, so they will make one load case for external wind, and they will make two load cases for internal winds. So maybe, so internal wind load case 1, internal wind load case 2, and then they will combine this to get all the possible directions. So I think what you have seen is this kind of a thing in your STAD model or ETABS model, that someone in their model must have applied the CPI load case like this, and that's why you thought, or you got confused, that why these wind loads have been applied in the gravity direction on roof. Okay, I hope your doubt is clear. So this is what is happening over there. Is it all right? Okay. So this was his question, engineer Devlin from Oman. Now we move on to next question, and this next question is from engineer Ketan Mahajan. He is from Jalgaon, Maharashtra, and he is a working professional. So what is his doubt? Let me just put it over here. And this doubt was also asked to me by Engineer Tosh Agrawal from Raipur. Same doubt he had asked me, and it's a, I would say, common problem that practicing engineers may face. So let's see what the doubt or query is. So he is saying, I have come across a project where I have to design a machine foundation on existing slab. So machine foundation is not on soil, not resting on soil, but on an existing slab. Has anyone else also come across this type of a situation? Hello, have you in any of your practicing in any of your projects come across this situation where a machine has to be, or an equipment has to be placed not resting on ground but directly on some RCC slab or beam? Okay, so you may mention it in your post in your comments. So this existing slab is 500 deep, and this is the reinforcement. Now the data given by machine foundation is that the RPM they have given 1500 RPM and its weight. What more data is required to design, and what should be the design procedure? So now there is no clear cut answer for this, no clear answer, because none of the codes deal with this issue of machine foundations resting on directly on slabs instead of some footing. But what I would say is that the logic you could apply over here may be the same that you may apply for machine foundations resting on soil. So I'm saying same logic can be applied, can be applied, or same logic as used for machine foundations resting on soil can be applied over here also. So in absence of any clear cut codal provision or any codal reference, we could apply the same logic that has been given to us in machine foundations. And what does that logic say? So that logic says that, okay, by the way, which is the code for this? Which is the code for machine foundations? Hello. Anyone in the comments? Those who are attending this live? Anyone knows which is the code for machine foundations? No one knows. So the code for machine foundations is IS 2974. IS 2974 series of codes is given. 2974 is the series of codes given to you for machine foundations. I think there are 4 or 5 parts to it. So part one, I think, if I remember correctly, is for reciprocating machines. Okay, reciprocating. Part two is for impact type machines, hammer type machines. Part three is for rotating machines, medium and high frequency, medium and high frequency. And part four is for rotating machines with low frequency. So I guess up to 1500 RPM, up to 1500 RPM, it is covered in, Mr. Jay Patel is saying, yeah, IS 2974 various parts. So up to 1500 RPM, it is covered in part 4 of 2974. So IS 2974 part 4 covers up to 1500 RPM. So your question is that a machine has this much RPM. So you can refer to IS 2974 part 4 for your machine. Just see the procedure over there. Important things to keep in mind is the frequency. Also, have a look at the amplitude, if this has any excitation amplitude, or what is the amplitude of vibrations. Okay, you check that also. And the design procedure or the checks, as far as I can answer over here, will be similar to what is given in the 2974 part 4. Usually these vibrations are damped by providing sufficient mass. So the usual strategy in machine foundations is the usual strategy is to provide sufficient mass. Okay, so usually we would provide mass two times or three times the machine weight. So whatever vibrations are there in the machine will be damped by the mass of the foundation. That is the general strategy we adopt when we are doing the machine foundations. And then we also check that there should not be any resonance, so that whatever is the vibrating frequency and whatever will be the frequency of your footing plus soil system, they should not come in resonance. There should be a frequency shift, or there should be a difference in their frequencies. But over here, in case of buildings, you if you try and go for three times four times mass, your building or your slab may become so heavy that your beam column sizes everything will increase. So in such cases, I think it will be best to install some dampers. Okay, install dampers, rubber dampers or viscoelastic dampers or whatever. So, or bearing pads which will dampen the vibrations. So install dampers to dampen your machine vibrations. That I think will be a more suitable strategy, because the strategy of providing mass to dampen the vibrations may be uneconomical in this case. As I just said, that you will require two times, three times the mass, which will lead to very heavy slab beam column sizes. So a better strategy would be to install some damping systems below your machine, just like springs or rubberized dampers, so that vibrations are taken care of. Okay, and once vibration is taken care of, mass can be taken care of by providing the sufficient sizes of beams, column, slabs. So I think you just look into this and take help of 2974 part 4. All right. So this was Engineer Ketan Mahajan. Next question is from Engineer Ashish Kumar. He is a postgraduate student joining us from Ranchi, and while designing a truss with 20-meter span in Stat Pro, what should be the specification? He's asking to be given. While designing a truss, Engineer Ashish Kumar from Ranchi is asking, while designing a truss with 20-meter span in Stat Pro, what should be the specification given for bottom chord, top chord, and struts? I have seen some people assign the top chord, bottom chord as truss members. So I don't personally like to assign this truss specification to truss members, because please remember, when we assign this truss specification, what happens that these members can only resist axial loads. They will not resist any moments. Give this specification only if, in my opinion, you should give this specification, truss member specification, you should give it only if you are going to have actual pin jointed members. Is it clear? So if you remember in your applied mechanics lab, maybe you must have seen in your experiments in BE first year or second year, you may have seen these trusses. And if you recall, those trusses used to be perfectly pin jointed members. Does someone recall? Perfectly pin jointed trusses. Each truss member was connected by a pin to the other member. If that is the connection type that you can create on site, then you can give the the specification as truss members. But usually in practice, we are not able to create these perfect pin like truss systems. So if you are not able to create it, I would say don't give truss member specification, because there will be some minor moment that will be developed in these members. Although the moment magnitude will be small, because of the configuration, structural configuration that we have created, the moment magnitude will be very small. But because these connections are not going to be perfectly pin connections that we are going to provide on site in actual practice in execution, so therefore whatever that small movement will come, it will come. So do not provide truss specification if you are not going to have perfectly pin jointed truss members on site. Is it clear? So short answer is don't give pin jointed or don't give these truss specification to members. Let it be designed for some small movement that is going to come in the member. Okay. Okay, so this was his question. And yeah, so we do not have any further questions in the Google form. So are there any questions in the live comments? I'll also have a look at the email if any questions have been asked over there. Yes, live comments. Anyone having any question? Because we have answered the questions in the Google form. Yes, please. Any questions in the live comments? So I do not have any questions in the on the email also. I'm just checking. Yeah, no questions. Yes, please. Any question in the live comments or should we close the session? Mr. Ketan Majan is asking, is there any course coming on design of machine foundations? Uh, yeah, I think we should because in our earlier course on foundation design, we did not cover the machine foundation topic. So maybe we can do such thing machine foundation not only on soil but also on buildings like you had asked, and also many people have asked this. So maybe we could do something in the near future. Mr. Jay Patel is asking, same consideration has to be considered for pump supported equipment foundation just like machine foundation. Yes. So for pumps, usually uh, pumps also we try to rest on the soil. So for pump supported foundations also the same logic as given in machine foundations uh, has to be used. The same logic has to be used. Mr. Ashish Kumar is asking in roof truss what type of connection we can do between column and truss. So again, that depends on the what you are going to execute on site. Mostly, one of the column you can have a pin-like connection. That means it's where rotations are allowed, but translation is restricted. On the other side, you could have a, and therefore I'm using the term roller like. I'm not using roller. On other side, you could have a roller like connection. If you are going to have roller like connection on one side, pin like connection on the other side, always remember to add plan bracings. Always remember to add plan bracings to provide stability to your column, because otherwise this column becomes a cantilever like member, isn't it? Fixed at the end, free to translate at the top, so it may become a cantilever like assembly. Therefore always add plan bracings. What I have written, add plan bracings to, what is this that I wrote, to pro add plan bracings to prevent cantilever action of your column. Okay. Now, when I am saying pin like, how do we do it for a pin like assembly? So, generally, the schematic diagram is like this, that this is my column. You will have a plate, you will have one plate over here. Let's call it base plate 1. This will be connected to your column. You will have another base plate. let's call it the base plate 2. Okay, this will be the truss bottom cord is connected to this base plate 2. So let's say this is my truss bottom cord, and then this is your truss assembly, whatever truss assembly you had over here. So this thing is connected to this base plate 2 by welding. This is my base plate 2. So you will have some general welding over here. Now typically we will assume this connection to be acting as a pin like connection, because it will not be able to restrain rotations beyond a certain limit. So this can be idealized as a pin like connection. And now these base plate 2 and base plate 1 are joined together by bolts. So what you will have is, you will have anchor bolts passing through this base plate 1, already cast in concrete. These are my anchor bolts, cast anchor bolts cast in concrete, and a portion of it is protruding above. And now you insert this base plate 2, which will have matching holes, and then you put the nuts and tighten it. So this base plate 2 will have matching bolt holes. Is this clear? And then you will tighten your assembly. If I were to show you a plan view, this is my base plate 2, this is the top base plate, and let me just draw a member. So this is the bottom cord, it will look like this in the plan, and then there will be bolt holes like this. So these will be the bolt holes that will match with the anchor bolts that you have placed, and then you will insert this assembly into these protruding anchor bolts and just fasten the nuts from the top. So this type of connection can be developed. And when you want to develop the roller like connection, the only difference will be that instead of having a circular hole, bolt hole, you will have a slotted hole type of assembly. So I'm just drawing the plan view. This is my base plate, top base plate 2, and this is my bottom cord, let's say bottom cord of the truss. And what do I have over here? That instead of having circular holes, I will have this kind of slotted holes, which will allow translation in one direction. Is this clear? So I am not having oval, and these slotted holes will be only in the base plate 2, the top base plate. In the bottom base plate, it will have circular holes and it will be fastened through anchor bolts. So this is having slotted holes in top base plate. Is it clear? So this will allow the bolt that is fixed, anchored in the concrete, and base plate 1, these are the bolts, it will allow the translation in this direction. Okay, so that's why. And anyway, movements were not, rotations were not restrained because of the type of system. So therefore translation is also allowed, and rotations are also not restrained. That's why we are calling it as roller like assembly. Okay, so this is how you could come up with some pin like and roller like system. Mr. Ashish is asking, it means in STAD also you should assign pin connection at column and truss joint. Yes, you could. Or you could assign a pin support at column top or moment release at column top. Okay, right. But always remember, if you are going to, as I just told you, if you're going to assign a roller like assembly or roller like support at one of the columns, always remember to add plan bracings. Otherwise this column will become cantilever like system and it will become unstable due to excessive sways. So always remember to add plan bracings. All right, any other question we have? So I think we have no further questions. Do we have any further question, please? So I have taken all the questions asked on the Google form and on the live comments and on the email. Mr. Arbaz Kazi is asking, if I am having a building where all the beams are gravity beams, then how will the lateral loads transfer? what is the meaning of gravity beams? So if your entire system, your beams are also just there to take the lateral loads, sorry, gravity loads, then you need to have some system which will transfer the lateral loads from the slabs to the vertical elements. So if beams are not there, maybe you will have to add elements like collector elements, but then those collector elements are also some sort of a beam itself. So if, let's say, your main beams are not there to take the lateral load transfer, they are not helping you in lateral load transfer, maybe you will have to add some connector like elements, or maybe you will have to add some plan bracings. Okay. Mr. Ketan Mahajan is asking in in continuation to his question on equipment foundation resting on slabs. He's saying how to design dampers. I don't know. Generally, these dampers are this damper thing is provided by the equipment supplier. So usually the equipment supplier will provide the damper, and they will design the damper for their equipment, accordingly provide the details. Mr. Ashish Kumar is continuing with his questions. If plan bracings are not possible as they will cause hindrance, then what to do? Then you do not give roller assembly. Then you do not give pin roller assembly to your truss column. Then you go for a pin like assembly. Do not give slotted holes then. Do not give slotted holes. And always remember, in truss like systems, it is always good because this connection is not a very uh, at best it can be called as a partial movement restraint connection. Okay, these connections are not very good that way, I would say. So it's always recommended, if you are using a truss column system, to add plan bracings and tie runners. Otherwise stability is compromised. So I would always recommend you to add tie runners and plan bracings in these truss systems. If you do not want to provide tie runners and plan bracings, do not go for truss systems. Go for rafters and columns which are rigidly connected to each other. Do you understand? So if you are going with truss column system, it will have its own requirements. So if usable area is a big concern, that means you cannot even I mean, this entire thing is usable below the bottom chord, right? But if you have to use this area up to this height, let's say, and therefore you are not allowing plan bracings or tie runner, I would say do not go with truss systems then. Then change your system, go with rafter column system. Okay, right. Uh, Mr. Padma Vijayan PV is asking, I have a doubt in foundation for G+3 building, hard strata at 10 feet depth, water table at 6 feet depth, side footings are eccentric. What type of foundation would be suitable for this? Is it feasible to design eccentric footings with tie beams? Yes, you could. Eccentric footings with tie beam is a perfect option of stabilizing the system. So wherever you are having eccentric footings, just add tie beams over there. It's perfectly all right. So if this was your plot plan and here you were getting some eccentric footings, you could easily tie them up in the direction of eccentricity with the internal footings. So if these are my internal footings, so in the direction of eccentricity, add tie beams like this. Okay, that's perfectly fine. Whether it is at 10 feet or 12 feet, that's not a concern. And if this is eccentric like this, add tie beams again in the direction of eccentricity like this. So hard strata, if you're getting at 10 feet, it's perfectly fine to provide eccentric footings and provide tie beams with it. Water table is at 6 feet depth. So in case of isolated footings, the rise in water table is not an issue as such, because the water pressure will act only on the surface area of the footing, which is being anyway counterbalanced by the large gravity load that you are getting. So in case of isolated footings, the water table is not a big concern. So whatever water table or water pressure buoyancy force is acting on this small area of isolated footing, that will get easily counterbalanced just by the dead load acting on this column, right? So as such, you do not need to be worried about the water table in case of isolated footings. I'm saying, suppose you had raft, then the thing becomes different. Then you will have to consider uh, the effect of water pressure, buoyancy pressure. But as long as you have isolated footings, water pressure not very important. Just ensure that during construction you have proper pumping uh, equipments available on site to pump out the rise rising water table excavated in your excavations for footing. Okay, all right. Any other question we have? So I think that's it then. If we have no other question, yes, please. Any other question related to steel RCC? So it's not necessary, as I've told you before, also to ask questions in the live comments itself. You could use the same Google form link, and that Google form link remains the same for all our sessions. So you could just put your query throughout the week in the Google form. We would take them up once every week, but you could put your queries continuously during the week in this Google form. So I've just put it in the live comments again, the link for the form where you could put your queries. So if there are no more queries, we can end this session now. I'll just wait for a couple of minutes to see if there are any more queries. Then we will close. So how many of you are practicing engineers? Those in the live comments. Those who are in the live audience, how many of you are practicing engineers? No practicing engineer. I think some of you are practicing engineers. What I know from your past interactions. Mr. Jay Patel is a practicing engineer. Very good. 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 Yes. Okay then. So that's it for this week. No more queries. We'll see you next week now. Next weekend. Same time we are trying to maintain these days. 11 a.m. Sunday. I think that is a better time than Saturday evening. Yes. Mr. Padmavijan is asking one more doubt. Yes, please tell me. Yes. I think he's typing. You could also send the doubts on WhatsApp if you find it more convenient. Mr. Padmayan is saying building width is 22 feet, no intermediate column, eccentric footings possible. In that case, what I will recommend you to do is, he's saying, and this is a common problem that we may face in small plots, because in small plots there is no open spaces that are left on sides. So he's saying this is only 22 feet, no intermediate column. So there is one column over here. In small residential projects, this is a common issue. So there are only footings on the sides, no internal column. and therefore all these footings are coming to be eccentric. So now if I provide tie beams 22 feet long, it will be problematic, more so for the contractor and for the client. Problematic because mentally they think, or they have this feeling that what's happening, this is very heavy or whatever, and you might face difficulty in such situations. So what my suggestion would be in this case, that you have a stub column. Stub column means a column that will only continue till your plinth level. Okay, and then you provide a tie beam to this. So at least this top column will carry some weight because of the load transfer from your plinth slab. So it will help the tie beam to hold it down. So assembly in sectional view would be like this, that this is your eccentric footing and this is your column on the plot boundary. I'm showing you a section now, and then this is your stub footing, this is your another eccentric footing on the other side of the plot. This dimension is 22 feet. So now what I'm saying, that you continue a stub column having a stub footing till the plinth level. So let's mark my plinth level over here. This is my plinth level, let's say. So this column will terminate at plinth level only, and these red columns will continue to your other floors. So whatever load will be there on the plinth slab, it will be transferred, some portion proportion of it will be transferred to this stub column, and that will help to keep this tie beam hold down, and this will be effective. Okay, all right. So that is one of the strategies you could adopt over here. Is that clear? So providing intermediate stub columns with, yeah, okay. Yes, Shamantika ji is also saying she is a practicing engineer. Yes, Shamantika ji. Yes. So, Paras Nagar, engineer Paras is asking how to design slabs for heavy point loads. So, for heavy point loads, analysis wise, you could refer to IS 875 Part 2 for heavy point loads on slab. Number one thing is always avoid heavy point loads on slab. Why to avoid heavy point load on slab? Why to avoid heavy point load on slab? Because heavy point loads will cause punching. Heavy point loads without any supporting beams should be avoided on slabs. So if heavy point loads are unavoidable, try to have a beam framing. That would be my number one suggestion. Suppose this is your assembly column, column, column everywhere, whatever, and suppose there was a heavy point load. So don't have a heavy point load acting directly on the slab. Try to provide some beam system, beam framing, okay, something like this, so that heavy point load has a beam resting below it. Now, because if you are able to provide beams, the issue of punching or issue of two-way shear gets converted to a problem of one-way shear. So therefore have some beam framing. If beams are not possible, that means it's absolutely not possible to provide beams, then check this slab for punching loads and for bearing pressures. You will have to check the slab if beams are not possible, although it will rarely be a situation in case of heavy point loads that beams are not possible. Generally these heavy point loads situations come up in industrial like buildings, Suppose you are resting some equipment and the leg of that equipment has a heavy point load. Usually those are the cases. So in industrial buildings no one minds a beam here and there. So but still, let's say if beams are not possible, check the slab for punching and bearing. So punching checks can be done as per the normal approach. Your heavy point load will not be a point load per se, but it will have some base plate or it will have some bearing width or support width. So you, if you have those support dimensions, from that you could do the punching calculations. Okay, right. Uh, Mr. Rajan Kamre is saying, is it possible hidden beam column to tackle punching shear? I think he is talking response to this heavy point load on slab question. Okay. Yes, Mr. Jay is an engineer. Swapnil Patil is practicing engineer. Okay, Shamantika ji is asking what is the difference between a floating column and a shifting column, which is acceptable in tall buildings. As far as I understand, shifting column, floating column may be something similar. Shifting column, I would say, if your column is continuously shifting or there are continuous offsets in your column along the story levels, I think in those cases some people call it as the shifting column. However, it's one and the same thing in my opinion. uh, a floating column or a shifting column. So what I'm trying to say is, suppose you have this tall building and these are your story levels maybe. So it's only a difference in terminology. These are your normal columns, and suppose this column was getting terminated at these levels, then these will be called as your floating columns. Okay, because they are getting terminated at a certain level. Below this, let's say your column grid is something different. So this can be termed as a floating column. And a shifting column, I don't know if you're in elevation. Suppose you had a, this is again my understanding, although I'm not sure about the use of these terminologies. But suppose, let's say that, how to say it? Suppose your floor plans were changing and a particular column maybe was having certain offsets in elevation. Maybe I call it as a shifting column. I am not sure. However, both are the cases that there is a vertical discontinuity in the column. Okay, which is acceptable in tall buildings as long as, I would say, your tall building is not located in a heavy seismic zone. You could come up with, or you could provide both of these systems, floating columns or shifting columns. Uh, as we know, transfer column is not acceptable in tall buildings. No, but it's a regular practice if you see tall structures, because of the architectural requirements that you have to satisfy, you have to provide floating columns. Because mostly in tall buildings what you find that on the periphery, especially in the peripheral frames where you have a tube system where you have closely spaced peripheral columns, especially in those cases you will often notice that there is a transfer girder given like this near the ground floors, and then there will be some columns which are at greater spacing, and above this transfer girder you have closely spaced columns. So this is a common feature in tall buildings that you see usually. So these systems are acceptable as long as you are not in a high seismic zone. So although these systems are not the preferred systems, but if you are not in a high seismic zone, these are often provided. So if you see tall buildings in Manhattan, especially even in the 1960s 70s, they used to provide floating columns, especially on the periphery tube systems. So see, generally we get confused because whatever tall buildings that you see, especially let's take up the case of US, where in which region do you see these tall buildings mainly? If you observe, where do you see these tall buildings mostly in the United States? Let's say, where do you see them? So you see them mainly on the East Coast. You would mainly see these tall buildings on the East Coast, right? In New York, especially, and East Coast of US is not seismically active zone. East Coast of US is not seismically active. So all these systems that you see mostly, uh, floating columns or irregular shapes or very slender structures, all those are on the or are all those are on the East Coast, which is not seismically active. If you go to the West Coast in the California state, in cities like San Francisco or San Jose or LA, you don't see super tall buildings, right? The tallest buildings, I think, in California is around 400 meters. So you would not see a 600-meter, 500 meters, those sorts of tall buildings you don't quite often see. Even if you go to the United UAE, that is the Gulf region is not seismically active zone. At least the parts of UAE, parts of Saudi Arabia, where these super tall buildings are being constructed, these are not seismically active. So as long as your location is seismically not active, I would say floating columns, shifting columns, transfer girders can be provided. Okay, hello. So that's my opinion. So although it's not acceptable or it's not preferred, acceptable is not a proper word, I would say. It's not preferred to provide discontinuities in seismically active regions, but otherwise you could. Okay. Uh, Engineer Krishna Birle is asking, what's the problem with 22 feet tie beam? I think stub column plus tie beam increases the cost. Yeah, you are right. Stub column and tie beam increases may increase the cost, but a 22 feet tie beam, sometimes you also have to think in this way that if you provide a 22 feet tie beam, your client may not be very happy with it. Okay, and clients, especially for these small projects, they trust the contractor more than they trust you, isn't it? That's the reality. That if a contractor says a particular thing, the client is inclined to believe the contractor more than the structural engineer. So, as a structural engineer, if you were to provide a 22 feet tie beam, the contractor would say that this is very heavy, and the client, in most cases, would believe that, and maybe they won't be comfortable in providing that tie beam, or at worst, they will change and appoint another structural engineer. So, because of this type of situation that you may face, I suggested it is better to have a internal column like thing and just provide a stub column and small tie beams. This is more acceptable purely with a viewpoint of client, what he or she thinks. Okay, and in many cases, some what may also happen that a very long tie beam can actually be very more costly than a stub column footing, because if you understand that the bending moment is proportional to square of your span. Okay, so if from 22 feet your tie beam span you are able to cut down in half to 11 feet, let's say, you are able to have a bending moment which is one fourth, isn't it? From a 22 feet tie beam, compare it with a 11 feet tie beam, the bending moment will become one fourth. So maybe your size also drastically comes down, and in some situations, a stub column footing system may come out to be cheaper than a longer tie beam system. So that is also a possibility that you should consider. Okay. Yes, very good. Any other question we have? No question. Very good. So I think that that's it. So today we had good interactive session, I would say. You could use, as I repeated, you could use this same Google form throughout the week to put in your queries. We would be taking them once every week during this live session. Okay. Okay. Bye then. So see you next weekend now. Same time next Sunday. Bye bye.